All right, folks, welcome to Young Minds segment number 4. We're going to talk a little more about Cloud Foundry. I'll give you advance warning. My Amazon demo unfortunately fizzled at the last minute. It was working fine this morning, but I'm having connectivity issues with Amazon. Even though I can actually talk to Amazon, I have some other kind of subtle issues going on. However, I will show you the demo the next time for sure. What I will show you today, with some luck, is how Cloud Foundry scales. I know we were trying to do that the last time, and that didn't quite work right, but this time we'll get it to work. I'm going to keep the line open and unmuted for everybody, so please be careful. If you can mute on your side, that'll be nice, because last time we got stuck with not enough people being able to ask questions. If it gets too noisy, I will do a *5 on my side. Remember to do a *6 to get out of it, all right? So what we're going to do today is to start to look at some details on how actually Cloud Foundry achieves cloud portability and cloud scalability. So let me give you a broad idea of what I've been able to accomplish so far, and despite the technical issues, this is something I'm sure I'll get over. We want to see what exactly we can do to help this to work, okay? So as you know, last time what we did was, I showed you how we wrote a simple Ruby, Sinatra app, and got that up to work locally, and then we were able to push it up to Cloud Foundry, and how Cloud Foundry took care of all the heavy lifting, the installation of the code and doing all that kind of stuff. So what we had locally was, I had a little Mac over here, right? And that's my keyboard over here, and that's me. And I wrote what I consider business logic, right? And the business logic was written in the language Ruby with the framework Sinatra. And I think last time we saw how frameworks really help a lot. They simplify the coding that you have to do tremendously, and we'll once again revisit one of the examples of that. And this is what we did. So what I then did was to construct a cloud external to myself with a free account from Pivotal. And these guys have their Cloud Foundry account. You can sign up for yourself, and you can absolutely do it anytime you like. And 60-day free trial, guys, free money, can't beat that. So what I then do is I take my code and I point it to a target over here, and that's the target. And the target is an ugly-looking thing. It's HTTPS API, which is the endpoint, .run.pivotal.io. Now, if you don't understand what that means, don't worry about it. This is called a URI, or as opposed to a, URL, Universal Resource Identifier. And if you notice, it doesn't have a file at the end of it saying HTML or something like that. What this means is this is not just a simple web page. And what this is actually an endpoint for a REST service. We'll talk more about REST later on and how that works. But what we're basically saying is, take my Cloud Foundry environment locally on my Mac and point it to this point over here. At that point, I did what's called a Cloud Foundry push,
it's mirrored,
which actually took this application and, Dave, anybody on the line, if you cannot talk, not muted, or let me go ahead and mute it.
Presentation mode is now enabled.
Okay, so I did what's called a CF push to basically move my application to that target. And prior to that, I had done a CF target to be able to move it over there. So let me show you how that works over here. So for example, what I have now is I'm connected to the Cloud and Pivotal. So if I do a CF target, it'll show you where I am. Hopefully you guys can all see the green screen over there. And hopefully this will actually work. Yes, it did. Hallelujah. So HTTPS API run Pivotal IO. And it says I'm the user, and I have a space called development and an org called Kartik-org. And if I check over here, I really have no application. I can do a CF apps, and it'll go and check and see, hey, you got nothing running right now, which is normal because I didn't ask for anything there. Now what I'm going to do is I'm going to do a CF push, and then I'm going to do, well, let me show you the code first. So the program I'm going to push is hello.rb, and it's a little different from, whoops, one directory up, okay? Hello.rb, and it's a simple program. It basically says, hey, if I go to the page / go and, say, Hello Central, and if I go to /info on the page, it says it's so-and-so time in Greenwich Mean Time, in case you're wondering. Very, very simple thing. Now you can also see how Ruby code actually can be used. There's a Ruby variable called time, and time.now is what's the time right now, and this is the application we're going to try to push over here, right? So we're going to say CF push, but this time we're going to say instances is 2. I'm going to push 2 copies of this. So keep our fingers crossed, guys. Let's reset the target once. Let's try to push one more time. Oh yeah, I know the problem, guys. Apologies. I had it on the wrong area here. I'm going to out of that. I have the wrong domain set over here, my bad. Right domain is cfapps.io. Let's try that again. So if all works well, in a couple of minutes you'll see this application, as I demonstrated the last time, going and doing what it's supposed to do, and it will go to the Cloud Foundry cloud. Once again, fingers crossed, guys. I'm doing this live. Always a risk that something will go wrong. Okay, so I'm going to do CF start. Now it'll start. Let's download the package. Now this is the DevOps I was talking about. This is the painful part every developer has to go through before they actually have a system ready. They got to build the operating system, install all the software, install all the packages over here, then make it all a writable, readable image, and then it will start to then launch the application. So you can see that it's starting to start 2 instances now. So now if I do a CF apps, oops, I will see that I actually have 2 of these running. So that's nice. So let's go and see, what this might look like. So if I say hk.cfapps.io, I hate it when demos don't work. Like I said, I'm having issues because I'm going through my MiFi right now. So Didn't come back with the URL. Well, guys, this is another demo I'll have to show you again because, you know, once again, I have no idea why this is not doing it right, but let's get rid of that. I think I fat fingered something or the other. Let's give it one more shot. After that, we'll proceed. So far, looks good. Target one more time. Okay, see, this time there was a difference. It said binding HKCF apps IO to hello, and that's a good sign. The last time it got confused because the first time I fat fingered it and I went up with the wrong manifest. It came down and it said, this is not quite what I want it to be. So it comes up with a path which can't be reached. Now that we've actually got it on the right path, it should hopefully work fine. So once again, fingers crossed. Keep in mind, my fumbling is because I'm about 3 days old on Cloud Foundry. Right? As people get experience with this is actually a much slicker experience than this. It generally reliably works almost every single time, all right? But we'll see in a minute if this works. If this doesn't work, we'll switch on to the presentation. I'll show you some more details. I really want to discuss some of the internals of Cloud Foundry's architecture this time. Okay, so I got a couple of instances running, and now you see it says the hello is available at that location. So now if I go ahead and try to do this, sure enough, I get Hello Central as I expected. And if I go to info, I get, hey, that's what I'm looking at. Now you see the actual time, which was the Ruby variable that I used. All right? So simple, basic application. But important thing is, I was able to get 2 copies of it with just about the same amount of effort that I took to get 1 copy of it. You can literally scale hundreds of copies of this at ease with a single command. This is worth its weight in gold. I just had lunch with a customer who works for a company which is an HR company. So they have very seasonal loads like enrollment. Enrollment, all of a sudden, you know, you have like 10 times the workload that you have for the rest of the year. And you have to commit that infrastructure when you're in-house, but they never use it. So they want to go to the cloud where they have elasticity. So they can have 10 times the capacity. Once the 2 or 3 weeks of enrollment is done, they can shrink down again and not run anywhere near that much. Make sense? So hence the power of what we do over here. Now this was the cloud for Pivotal, and if you notice, I did a target over here, and after all my fudging and all that kind of stuff, I actually did end up with an application at an endpoint which I wanted, cfapps.io. And when I pointed my browser, when you pointed your browser to this, and by the way, the application is running. Any of you can use your mobile phone and check the application out. I literally wrote, modified, and pushed the application onto the cloud, and you as another user over here can easily access the same information over here. Now, what I'd also done over the weekend, which I will not have a chance to show you at this point, is really that I created a second cloud. And I did this at Amazon. Amazon Web Services, the infamous Amazon Web Services. And if you're wondering what that looks like, let me show you what Amazon's EC2 console looks like. So if you notice here, highlighted here is the machine that I'm running right now. Now I took an existing machine for Cloud Foundry Micro, and it's a simple enough machine to sit and build, it took me a while to get to the point where I could actually build and deploy machines. I had to get an external IP address. I now have a DNS, domain name for it, and I haven't activated it yet, but I went to GoDaddy, paid $10, and I got it. By the way, my grand total bill for all of this at Amazon is probably about $2 after working through this. Now, $2 may not seem like much, but it does add up as you go times 365 for a single machine. I could probably build a machine for about $400 in my basement. So you look at that and say, well, is it really worth it? Yes, it is, because it would have taken me 2 weeks to get to this stage. I was able to get to this stage in less than a day, and henceforth I can go and do a hell of a lot more. So this is what the instance looks like, and you can do a whole bunch of stuff with it. In fact, I have that instance actually running and available over here. So I'm logged on to that system. Turns out that it's an Ubuntu system. Oops. That's not responding too well. No worries. Like I said, I have network connectivity issues which are stopping me from doing a whole bunch of stuff. But what I did at Amazon was actually very much the same as what I did elsewhere. Same process I followed, and I assigned an IP address over here, and I said, let me choose a different target here. And I used another such URI, and I can tell anyone who's interested how to get that URI. But once I had that endpoint here, behind here is my machine, which I just showed you, the one that's running. And I was able to deploy the same application with absolutely no changes, so somebody else over here could also access it when they pointed over here. Now, this is very, very powerful. I can deploy an application here onto Pivotal. I can take the same application with the same commands. I can deploy that to Amazon as well. 2 different clouds, and I can literally move it from one cloud to the other within minutes. Now, one of the limitations I have right now in the Amazon case is the fact that I used a single machine to basically be able to deal with all the services for this. And that's the reason why this is a particularly hard kind of thing to run with. But you can see here, there's a whole bunch of running processes on that machine. There are things called NATS, Health Manager, Cloud Controller, Warden, all that kind of stuff. So let me give you a feel for how Cloud Foundry does its magic, all right? So just for now, just keep in mind, Amazon machine image, and that's what we work with. And this is the external IP address that I assigned to it. And then I can sit and operate it just like I did the other cloud from Pivotal. I got to tell you, the cloud from Pivotal is a little more reliable than Amazon is. But I'm going to say it's probably because I messed up rather than an intrinsic fault in Amazon itself. So how does Cloud Foundry really do its magic? You saw Cloud Foundry at the bottom working on a cloud from Pivotal, and you saw it working on a cloud from Amazon, right? And what we saw was a developer, i.e. me, writing code, and I wrote it in a Mac. This is generally speaking written in some kind of integrated development environment. If you hear the word Eclipse, that should ring a bell. It's a very common IDE. So the developer writes some code in whatever, their favorite language, Java or Ruby or something like that. They may even choose to write it in some framework such as Spring or Rails or, in my case, Sinatra. And once they have the app and, they say, hey, man, I'm ready to test it and do something to it, what they do is they deploy it onto Cloud Foundry. And I'm representing Cloud Foundry with this box over here, but really there's a lot of distinct pieces that go in here which make this magic happen. So the code gets to Cloud Foundry using this URI, which I've shown you as the target. And in the case of going to Pivotal, it's api.run.pivotal.io. There are other URI endpoints for other types of clouds, but it doesn't matter. It's a character string. You basically get to it, and that's all you really need, right? So you deploy this code over here, and the first thing that happens to that code is it hits a layer called a dynamic router. And the dynamic router is actually a very interesting thing. It routes these URIs. So when a URI request comes in, it says, I may have the application running in 10 places, right? Remember, we scaled it to times 2. I could as well have scaled it to times 100. So which one of those applications should I really hit is the question. And that is what the dynamic router does. So if I went from 2 to 100, I added 98 instances here. Someone needs to load balance between these, and that's what dynamic router does. Then the control goes over to something called the cloud controller. And the cloud controller is actually sort of the brains of the operation. Attached to this is a little store. It's a blob store. And this could be Isilon, this could be Atmos, it could be Amazon S3, it really doesn't matter. For a small deployment like what I have right now, nobody really cares. It could be anything, it could be, just a disk file. But this is where it keeps all the data that it gets, the code that I load, the operating system image that it's going to build. All of those things are basically maintained over here. It's a little blob store for internal use for its own purposes. Then I have two pieces which are sort of more administration related. One is UAA, which is the Authentication and Authorization Service. This is what makes sure that I am authorized to be deploying to this cloud. And the other is something called Health Monitor. And Health Monitor, like the name suggests, monitors the health of the entire system. It makes sure that all the instances are running the way they should and, everything is happening the way it should. Now, so far, it's just basically administrative controls. So then what you got is, in a layer after that, you have two key services here. All right? There's something called a service broker. And what a service broker does is it says, hey, you know what? You're not just an application. You got data somewhere, right? You have a database or a NoSQL store or files or something like that which you need to access, or an in-memory fabric or Hadoop. So there's a bunch of data services which are built into Cloud Foundry through connectors. And some of the common connectors are, we have a connector for MySQL, and the open source version of Cloud Foundry has support for Postgres as well built in. There's support for a key value store called Redis, and we will talk about key value stores, okay? No worries if you don't understand what that is. There's fundamental difference between relational database, which is what MySQL is, and Redis, which is a key value store. There are other key value stores also. HBase is a common one. Gemfire actually is a key value store. It's an in-memory key value store, but we'll get into key value stores later. All right? And then it also has a connector built in for Hadoop, so which is kind of cool. It's like, oh my God, I got a whole bunch of stuff over here which I can use easily. I just have to go through a process called binding to the service, and that also is something I can control with Cloud Foundry, just like I did over here. Remember, I use these CF commands over here, CF push, CF target, CF apps. I can bind also with similar commands to whichever service I want, and that binding occurs at runtime, and that effectively gives me a database which I can work with, or a NoSQL store or Hadoop that I can work with. Okay? Then there's another layer which is over here called user services, which means, someone might say, well, that's not what I use in my shop. I use Oracle, or I use DB2, or I use whatever kind of data service. You can define data service for your own internal data services and also invoke them and bind them at runtime, and that works as well, right? Then we come to, on this side, we have something called a droplet execution agent, and the basic, thing that Cloud Foundry works with is something called a droplet. And I think you guys should have seen that when we were loading up this application. So when we went through this, we went through and we installed the right Ruby and all the racks and all that. And ultimately, it came to this thing where it said uploading droplet, 23 megabytes. The droplet is the fully executable version of the code which will actually run in the runtime, that environment that you're creating. As you note, the runtime environments are many. I could use languages, Sinatra uses Ruby, Spring uses Java, Rails uses Ruby. There's a host of such languages which are supported over here, and the runtime environments with that. So Java has a Java virtual machine and a Java runtime environment, for example. All of those are ones that are over here. So the DEA runs the apps, and all the heavy lifting that you saw with the DevOps, that is actually building up and installing all the software and the dependents, that is stored in what's called a build pack. Okay, for the pairs aficionados, Cloud Foundry's build packs are also compatible with Heroku's build packs. Heroku is another cloud platform as a service provider. And then lastly, it has a layer which is used for logging. Right? So the application comes in, and then there's an environment for it to run in. The DEA scales. You may have one or more of these DEAs, and you can therefore have one or more copies of the data. So DEAs are where you actually deploy applications very rapidly. If you want to go down a little deeper, DEAs use a special Linux containerization technique called wardens. They are like very lightweight virtual machines. So each time I say deploy a second copy of the hello program, it'll use Warden to create a little zone where it deploys it with its own independent stuff. If I want to create 100 of them, it'll just spread this across as many DEAs as possible, and it basically manages it. All this communicates back to the health monitor, so everything knows about it. In fact, everything communicates back to the health monitor. Health monitor keeps track of everything. If something is wrong with the expected state, it tells Cloud Controller something is wrong. Cloud Controller jumps in and fixes it. Now, how do these things communicate with each other? There's a messaging service called NATS. I'm not going to say much about that. It's a simple pub/sub infrastructure. All of these guys logically go through NATS, and NATS will basically take the message to where it's intended. And then we come to the most interesting layer, in my opinion, something called BOSH. BOSH is the interface between Cloud Foundry and the infrastructure as a service. Because what are these? These are infrastructures as a service. Cloud Foundry will support something that's vSphere-based, and it'll support something that's vCloud-based. This, by the way, is not yet GA. This will become GA sometime in May. And this is VMware-based. It'll do Amazon Web Services, and it'll also do OpenStack. So very cool set of things it works on. And all BOSH does is it has a handful of primitives, about 9 or 10 primitives, and it says, fire up a VM, fire up whatever, get some storage, get some network, get all the stuff I really need for this application, because I'm going to figure it all out for you. So what happens to the application is it goes through this entire life cycle here, and it says, I'm going to go and choose all these pieces here. I'm going to get to Dynamic Router, go to Cloud Controller, get authenticated, bind any services over here, go to BOSH, get the VM, install, get all the pieces I need, get the storage, get the network addresses I need, then go to a droplet, and the droplet will then execute and scale, and then it gets monitored with Health Monitor, and that in turn will communicate to Cloud Controller. You get the picture? That's the internal orchestration that's done in here, so the DevOps is built in, which is a huge benefit for our customers at the end. Right, so this is rough and tough, the architecture for Cloud Foundry. Once a droplet is done, what the Dynamic Router does is it says, I'm going to expose another URI so you can access it. So in our case this time, that URI was my HKCFApps.io, which you saw me set in the configuration files, and bingo, I have something which I've done. Interesting thing is, this is where the work gets done. This is where the business logic gets dealt with. This is where the developer does the stuff. They do not want to deal with this. This is why when you go to a development shop, they say, I have something which is going to take care of all the stuff, the load balancing, the management, and the operations, and the authentication, and the health, and most importantly, the scaling. They love it. And this is the reason why time after time again we will get into these kind of situations and people will say, this is what I'm really looking for from a development standpoint in my shop. I have applications I need to scale up and down. I don't want committed resources, and I don't want to deal with the actual virtual machines itself, which is what, you know, AWS and OpenStack and vSphere environments do. They give you VMs and say, have at it, do what you want with it. And in the absence of anything else, they have to use DevOps tools. We talked last time about Chef. There's another one called Puppet. There's a series of these DevOps tools which can be used. We don't need these in a Cloud Foundry world because Cloud Foundry basically does the whole thing for it, right? So once again, guys, I apologize. I'm a little past 4:30 at this point. So I think this is a good space to pause. But understand that this, you know, whole idea of platform as a service is getting a lot of traction. Like, for example, if you look at the landscape, there's, you know, Cloud Foundry, which we all know and love. Heroku, which is another platform as a service, rather similar to Cloud Foundry, is very popular as well. Amazon Web Services, thanks to Smithy for pointing this out, has its own platform as a service called Eucalyptus. I hope I'm spelling that right. And Google has their own platform as a service too, which is something I believe called Google App Engine. And Microsoft also has their thing called Azure, right? Now, all of these, you know, have one important characteristic. Most all of them are off-prem. Although I have some questions about Microsoft, I think they are looking to offer something on-prem. This can be on or off-prem. For example, we can host this on VCHS. We can host this on AWS. We can host this on a vBlock internally. These are not really geared to do stuff like that. Amazon is looking to do stuff like that. There's some dangerous moves they're making in going on-prem. But understand that a lot of these have very similar properties to what Cloud Foundry does. So it's not like we're alone. Cloud Foundry alone won't win the battle. You have to position the whole platform, which is Pivotal One. And what Pivotal One is, Cloud Foundry, GEM, GPDB, the Hadoop for Pivotal, all this coupled together with Spring and with Agile development. This platform is excellent for the next-gen applications that we have, and all of this will effectively run on a vBlock if we need to, or on some other infrastructure as a service if we want. So let me stop here and open up for questions, guys. Once again, I had to mute in the middle. I'm going to try to unmute. You know, your mileage will vary, but if you *6 on your end, I think you'll be able to ask questions. I will open up my chat just so I can see anybody who's doing this. And I hear from Jason Bodette just pointed out that you know, that Windows Azure does have an on-prem offering. Yes, and a couple of other comments. Yes, Red Hat does have platform as a service. It's called OpenShift, and this is from Red Hat. But there is some interest in this from our customers, and certainly that looks kind of interesting. But I have not seen massive adoption of that as yet. Also, somebody asked the question, what about Scrum? Scrum fits into Agile. So if you remember from last time, Agile was the process by which we we actually went and started to do stuff in a very, very interesting fashion on how to change the development for it. Just to remind people, let me show you again what Scrum does. In Scrum, what happens is, that you start with a bunch of software which you have to develop. Typically, a business comes and says, hey, listen, I want you to build me this app, and I got these 50 requirements that I want to fulfill. And this is called the backlog in Scrum terms, okay, in Agile terms. So we know we got to get to it. Agile differs from traditional waterfall in the sense in a waterfall scheme, you say, okay, let me design something that satisfies these 50 requirements and move on with it. In Agile, what you say is, what are your top 5? And I'm just a random number, but it's a small number, right? And it says, let's work on just the top 5. And it takes that little chunk of work, which is called a sprint, and then a sprint goes through a cycle of development, which is typically about 2 to 4 weeks. At the end of that cycle, you get usable code, which corresponds to these top 5, which you have already, and it's fully running code. In the process of getting to this fully running code, there is daily meetings, and these are the ones called scrums. So if Roshni, I know you were asking about it, so that's basically it. So another question from Shane McKenna, which is when you ran 2 Hello World applications, was this 2 instances or 2 programs? It was the same program, 2 copies of it running in 2 different DEAs. All right, so going back to my slide over here, actually not even this one. So if you recollect, what I had here was that when I write code, the DEA is what scales it. So my first copy went to one warden zone, and the second copy went to the second one. So the first one went to the first warden. A DEA decided to put the second one in a second warden. The code itself was identical. What I did was to make multiple copies of the code. So if you go back and look at this, this is the actual code. So it doesn't tell you which instance it is running on. I will enhance it so it announces which instance it is. So it's simple enough code. It says Hello Central. And if I say, hey, you know, what about if I, just discovered I can't really operate the mouse too well with my left hand. All right. So if I do info, it comes and says, hey, that's the time right now, and that's what I want to work with. Hope that answers your question. Okay, so that's what a Scrum is. Okay, next question from Dave Dickerson, actually from Joe Vranikar. Or Joe V. I'm assuming that's Joe Vranikar. With Bosch essentially managing the DevOps function of the application deployment management configuration, how do you see this affecting our customers who are investing in Chef and Puppet skills to manage DevOps? With true platforms, these skills are obviated. That's absolutely correct. A fully functional PaaS platform should obviate the necessity to use any external DevOps, in my opinion. Chef and Puppet are used extensively still, more from a governance standpoint, to make sure that you have exactly the right build, and they usually use inside the enterprise, although I'm seeing them also being used in Amazon. Amazon has a Chef service you can bind to, and you can use Chef to do your orchestration with the recipes that you create and cookbooks that you maintain. When you do this, okay, someone pointed out that's Joe Viviano, not Joe Vranikar. So are Chef and Puppet still viable? Not in a true PaaS. Now keep in mind, Cloud Foundry, for all its advanced work, is still not quite a full-fledged development environment for everything that you want to do. So let me point out a few more things about Cloud Foundry itself when we go to our layer cake over here. Now, the DEAs can support a lot of runtime environments at this point, but the runtimes are sort of limited at this point. right now, most of the Java code runs in Tomcat, and or I should say Spring TC Server, right? All of us know the Spring TC Server is the industrial version of this, and it's very well integrated with Spring. Tomcat is not a fully fledged JEE environment, as they say. It is missing a few pieces to be fully JEE, and applications like WebSphere or WebLogic, which is Oracle's container technology, they use a full JEE stack, while Tomcat is a little short of that. So people may still have, old-fashioned JEE enterprise apps, which use what I call enterprise Java beans, which are not fully supported in Tomcat-like environments. So in cases like that, you still use old-fashioned ways of doing that. I provision a VM. I use Chef and Puppet to do the DevOps, to build it up and to scale it, and then I run my EJBs on it. Now, more and more, I'm noticing that WebSphere apps especially are moving over to Tomcat. Even more so because IBM has released a certain version, a stripped-down version of WebSphere, which is called Liberty Core. And what Liberty Core it does is it really is basically JEE minus Java messaging services. And so for the most part, it does everything that full JEE does. And Liberty Core is supported on Cloud Foundry. So many of those limitations are going down. So that's one of the reasons why, I believe that in the long term, platform as a service style DevOps will absolutely be the way to go. Scott Nolan also points out through chat that there's a customer who develops Agile Scrum and uses Puppet and uses Amazon, and they're looking at Google's compute engine and looking to see how to go from one to the other. I would absolutely say that yes, Google Compute Engine, which is part of Google App Engine and stuff like that, is a platform as a service, and a true platform as a service should sort of want to be able to get away from that. Now, Scott also says that, in a lot of ways, people think that Amazon is an absolute lock-in. It is a lock-in mainly if you have your data stuck over there. So one of the reasons why we want to convince people that they should still have their data in the data center or have the ability to move the data back into the data center is so they have cloud portability in moving their applications from one cloud to the other. Amazon's lock-in can be avoided if you write the code in a very specific way. If you don't actually use any of the Amazon API features, then if it's just portable Java code or portable Ruby code, like we have in the case of Cloud Foundry, you can conceivably run that in a different environment as well, which supports the same runtime environment. So the lock-in at Amazon is not as intense. The other area, of course, is if you use any of their data services heavily, and thanks, Joe, for pointing that out. If you use Elastic Block Services or Provisioned IOs or Amazon S3 and you're used to those APIs, then you start to get locked into the way that they're doing it. They're running in a pure platform as a service while you connect and bind to data services externally is an easier way to get out of. You want to not get them locked into Amazon APIs. That's really what makes it very, very fixed, okay? Any other questions, guys? I mean, I like chat, but if anybody wants to give me give me something else, then please go ahead. Dave Dickerson did ask another question in the middle. Are you aware of any way to map the DEA back through the hypervisor and onto the physical? No. The layer, as far as I know, no. I'd never consider myself an expert in any of this. I'm still learning. But BOSH sits between the DEA and the infrastructure as a service. So you'd have to pass through BOSH to be able to get here. There are open source implementations where people have replaced BOSH with an orchestration layer written in Chef. This was done several years ago. I've really not seen much uptake for it in the community. but it is there. The code is there on GitHub. If anybody's interested, they could go and have a look at Chef, and that's certainly, you know, something you could do. But far as I know, there's no real sort of, you know, physical way to be able to do this. All right. Any other questions? By the way, great questions, and you know, pretty tough ones. Keep in mind that regardless of the extremely seductive posture that we have with Cloud Foundry, and the fact that we have a great market position with Cloud Foundry, this space is no cakewalk. Our strength actually is more along the lines of, hey, we can deploy it in-house on a vBlock, and we can do it off-prem. And the fact is that we are not just a one-trick pony. We got a whole product portfolio. Cloud Foundry, Gemfire, Greenplum, Pivotal, Hadoop, with a Spring and Agile framework around it. I should not forget RabbitMQ. This is a great AMQP-based messaging tool. We'll talk more about Rabbit. Sales guys, if a lot of these terms don't make sense, no worries. We're going to be revisiting all of these things in more detail. But I hope you guys have got a feel for how Platform as a Service works and how Cloud Foundry does some of its magic with taking, and how languages and frameworks work, okay? All I want is you guys to leave with this, with an understanding of how to have a cocktail conversation about this. I'm going to put the recordings, make the recordings available, of course, and I will capture the slides that I made over here, put them in a presentation, and I'll send them out. Any final thoughts, anyone, before I let you all go? I really didn't want to go over 45 minutes. Okay, if that's the case, good luck and good selling, guys. Close the quarter strong, everybody who's listening. All right? Take care. Bye.